Lesson 3, problem solving with linear inequalities. So, whenever you have a word problem, I want you to read through the question all the way and underline important information. So, Carmen has up to $15 to buy seeds. A package of vegetable seeds costs $1.50. A package of flower seeds costs $2. Write an inequality to represent the total cost of seeds. So, we're going to choose our two variables. So let's let V equal vegetable seeds, and let's let F equal flower seeds. So we know that we have up to $15 to buy seeds. So that means you can't spend more than it, but you can spend less. And you can go up to, so it also includes 15. So we're going to use the less than or equal to sign. Then we have our veggies and our flowers. Now veggies cost $1.50, so we need to times the amount of veggies by $1.50 and the amount of flowers by 2. So $1.50 times however many vegetable seeds you buy plus 2 times however many flower seeds you buy will be less than or equal to $15. So there is our inequality to represent the total cost of seeds. So we want to graph this inequality. So first off, we're going to make one of our axes veggies, so our V's, and we're going to make the other axis flowers, so F. So we are going to find our F-intercept and our V-intercept because that's going to be the quickest way to graph this. So we're going to find our F-intercept. So to find our F-intercept, we have to make V equal to 0. So 1.5 times 0 plus 2F equals 15. Divide by 2, and F is equal to 7.5. So we're going to plot a point that is 0, 7.5. So let's do that first. So 0, 7.5. So 1, 2, 3, 4, 5, 6, 7.5. Right about there. Then we're going to find our V-intercept. To find the V-intercept, we make F equal to 0. So 1.5 V plus 2 times F is equal to 15. We're going to divide both sides by 1.5. So V is equal to 10. So we're going to plot another one at 10, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. So to graph this, first we need to check if it's a straight line or a broken line, and because it's less than or equal to, we know that it is a straight line. So we will draw a straight line between the 2 points with a straight edge. Now, we need to decide where we're going to shade. So we choose our test point, so let's choose 1, 1. So 1.5 times 1 plus 2 times 1 is less than or equal to 15. So 3.5 is less than or equal to 15. So this works, so we know we're going to be shading below. Now because you can't buy half of a bag or a bag of seeds. You can't buy half a bag of vegetable seeds or half a package of flower seeds. We know that this is going to be discrete. So we will use stippling to shade below the line. So put a dots on the corners. If you want to shade lightly over top, you can. But it should look something like this. And there's not that many dots to make, so you can handle making them right now. Okay, so there is our inequality. Okay, the first question is asking us to choose 2 different solutions that she can spend up to $15. So if we say 1, 6, that means she would buy 1 veggie and 6 flowers. And we know that we can do that because we have 1, 2, 3, 4, 5. There's that point right there, which you can't see because I just used gray. So we can test to see if that works. So 1.5 times 1 plus 2 times 6 is less than or equal to 15. 1.5 plus 12 is less than or equal to 15. So 13.5 is less than or equal to 15. So we know this works. If you chose another point, say 2,6. Right next to it, right here. So that would be 2 veggies and 6 flowers. So 1.5 times 2 plus 2 times 6 is less than or equal to 15. 3 plus 12 is less than or equal to 15. And we know 15 is equal to 15, so this also works. So any of those dots will count as an answer. Okay, question C says, can she buy 5 packages of veggies and 4 packages of flowers, and we want to justify. So we're going to go onto our graph. So 5 packages of flowers. So 1, 2, 3, 4, 5, and 4 flowers. So that's right here. So it's just slightly above the line. So because it does not fall within the shaded region, we know that she cannot buy that combination. And your justification would be just to say it's not in the shaded region, the solution region. Or you could plug it into the equation. So 1.5 times 5 plus 2 times 4 is less than or equal to 15. 7.5 plus 8 is less than or equal to 15. 15.5 is less than or equal to 15. So it's just outside of the solution region. The next question says we want to find the most she can spend and still have change. So we want to find a dot that is really close to the line but does not touch it. So the closest to the lines would be probably at 3 and 5 right there. That's pretty close. Or at 7 and 2, which is 1, 2, 3, 4, 5, 6, 7, and 2. That's really close too. So we can test to see how much change she would have. So let's do 3 and 5. So we have 1.5 times 3 plus 2 times 5 is less than or equal to 15. 4.5 plus 10 is less than or equal to 15. 14.5. So you'd have 50 cents change. We can also try 7 and 2. So 1.5 times 7 plus 2 times 2 is less than or equal to 15. So 7.5 plus 8 is less than or equal to 15. Just kidding. $10.5 plus 4 is less than or equal to 15. So 14.5 is less than or equal to 15. So either one of these, you get 50 cents change. Okay, example 2. A sports store has a net revenue of $100 on every pair of downhill skis sold and $120 on snowboards. The manager's goal is to have a net revenue of more than $600 a day from the sale of these 2 items. So we want to find the combination of ski and snowboards for this to work. So let's say let S equal the skis and B equal the snowboards. So we know that when we add them together, so S plus B, we want to have a greater than or equal to income of $600. We know that skis, you make $100, and snowboards, you make $120. So $100 times however many skis you buy, plus $120 times however many boards you sell, is greater than or equal to $600. So we know that it's going to have a solid line, and because we can't sell half of a ski or half of a snowboard, We know it's discrete, so it's going to have stippling. So we are going to find our s-intercept and our b-intercept. And let's label our x-axis, our skis, and our y-axis, our boards. So 100, when we have an s-intercept, we know that b is going to be equal to 0. So 100s plus 120 times 0 is equal to 600. Divide by 100, and we have s is equal to 6. So we will have a point at 6, 0. So let's plot that in. 1, 2, 3, 4, 5, 6, right there. Then we will find our s-intercept, so our b-intercept, so s equals 0. So 100 times 0 plus 120b is equal to 600. Divide both sides by 120. And we know that b is equal to 5. So we have a point at 0, 5. 1, 2, 3, 4, 5, right there. And so we're going to draw with a straight line through the points. That wasn't through the points. And now we want it to be greater than 600, so we know that that's going to be above the line. So we want to dot above the line. And there is quite a few dots on here, so if you just do a couple to let me know that you know where that you're not shading, but that you are dotting and using stippling, that is good enough for me. So there's dots above the line. Okay, so we want to find a combination that will work, so really literally anything in the shaded region. So let's pick right here. So 1, 2, 3, 4, 5. That's 5, 1, 2, 3, 4, 5, 6. So we are going to have 5 skis and 6 boards. And we're going to plug that in. So 100 times 5 plus 120 times 6 is greater than or equal to 600. So we have 500 plus 720 is greater than or equal to 600. So 12,020 is greater than 600. So this is a solution that works. And anything where there's a dot would also work.